This is a conjunction, right? You drop T, right? So you get not B, right? And this one, this is not T is false, right? False and B is what? Is false. So you get not B. So by the way, I think I made a mistake earlier. The real condition should be this one, not B, not false. Okay. In this case, it should be not B. If it's false, if PA equals false, what it means? It means this condition can never be satisfied. That's different, okay? So I don't want to make the correction. It only says B has to be false. It does not mean PA has to be false, okay? So the real condition is this one. If we want to make this expression true, B has to be false. Okay? Again, it is kind of mechanical, right? Okay, that's what we want. We work with computers. Computers can, if you have a mechanical process, the computers can do the simplification for you. Any questions on this? That's how you derive the condition. How you make A active. If you want to make A active, you have to make this expression true, and that means B has to be false, and that is consistent with what makes sense to us intuitively. Do you want me to do the second one, or you want to go to a more interesting one? Yes. Okay, I can do the second one, okay. And when we see some more interesting example. So for the second one, again, like if you look at this these two Boolean expressions, they are symmetric, right? So QA would be the same as B, you just replace A with. So A equals true, then that means you have to replace every occurrence of A with true, okay? And what you get for this one? True? B. B, right?
Do you mean Q or P?
See that again? Well, I'm trying to, so P is the predicate we're trying to test. And A is the clause we want to test. These are two predicates, or two examples. Okay. So like you can imagine like this, you have two if conditions. When you test one condition, they are independent. So this is B, okay? You can drop. Yes. Okay, we can drop two from a conjunction, right? So get the second one as false. This would be false. Then you have to compute this condition. False. So you're going to replace this predicate with B exclusive or with F. Okay. And when we do what we did earlier, so this we want to get rid of the exclusive or operator. So it's B and not F, or not B and F. Okay. And you simplify this. So this is true, you can drop it. It's B, and this is a conjunction, you have a false. So this is a false, okay? And you can drop the false in a conjunction, so you get B. So what this means is that if you want to make A active, you have to make B true and make this condition true. And that is consistent with what it says from an intuitive perspective, right? If you want A active, Otherwise, if B is false, then the impact of A would be masked by the value of false. Okay. Let's look at more interesting example here. Okay. Okay. I wanted to look at this predicate. Can you tell me if I want to make A active, what value B has to we have to give B? I want to make A active. What value has A B? It may not be that easy to figure out, right?
Yeah.
Okay, can you tell me like just what value I have to give to B to make A active? Or false? Let's try it. If you give false to B, you get this, right? A and not false. So this one would be false, right? And this one would be A, right? Is that right? Okay. Okay. Very good. So you can drop this one would be A, right? What does this mean? So if you flip this value, you would flip the entire predicate, because the predicate reduced to this value. So if you give false to B, that would make A active. That's true. Okay. What value, if I want to make B active, what value I have to give to A? If I give, what let me say? Yeah. What if okay, let me say, what if I give true to B? Would that make A active? Come back to this one. If I want to make A active, if I give true to class B, would that make A active as well? So we have just what we have checked, if B takes value false, A is active, right? So my question is that what if B takes value true? It's also active, right? Let's check. If this is true, this is not true, right? You simplify this would be A or A and false. This one would be false. And you can drop this one so that so P would be A, right? You're also going to make A active. What this means? What does this mean? So no matter what value you give to B, A is always active, right? So it means A is constantly active. You don't have to give any particular value to B. What value, if I want to make B active, what value I have to give to A? If I want to make B active, what value I have to give? True. Let's try it, right? So if I give true to A, so the predicate would be true and B, or true and not B, right? You can drop this one, is B or not B, it can be true, right? What does that mean? So P would be true. What does that mean? It means B is not active, right? Because no matter what value you give to B, true, I mean the predicate will always be true because the predicate is constantly true, right? So what does that mean? If you give to false, I think it's the same, right? You can try, if I replace this value A class, if I give false value to class A, what I get? False or false will be constantly false, right? What does that mean? It means B cannot be active. There's no way for you to make B active. Okay, that's what we do, like without going through the process. We look at earlier. Okay, we just kind of check, right? So what I'm going to do next is that I'm going to follow the process. Okay? Let's see if we get the same conclusion. Okay. So PA equals 2 would be the predicate we get by replacing class A with the constant value true. So true and B, or true and not B, right? If we do the simplification, would be B or not B would be true, right? For this predicate, we get false and B or false and not B. So we get false or false, okay, false, right? Then the condition we have to satisfy to make A active would be the exclusive OR of these two predicates would be true, exclusive, or false. What is this? True. It's true, right? So what does this mean? So the condition that we want to satisfy to make A active is constantly true. So that means A is always active, right? That's consistent with what we have seen earlier. Does it make sense? And we can do that for class B. I see some of you are taking notes, so I'm going to wait for you guys to finish taking notes. Can I wipe this out? So what I'm going to do next is to do it for class B. So what condition has to be satisfied to make B active? Okay. So A equals B equals true. What we get is A and true or A and not true. Okay. With A, we drop true from a junction or false. That would be A, right? And for this predicate, A and false or A and not false. So this one would be false or A, right? This is true, you can drop. So this one would be what? It would be A as well. And the condition we want to satisfy would be the exclusive OR between these two. B, right? Yeah, B, sorry. So would be A exclusive or A, what is this? Has to be false, right? There's no way we can make this exclusive or expression true. Of course, you can still do what I mentioned earlier. If you want to double check, okay. So this one would be A and not A, or not A and A, right? Okay. So it would be false, or false would be false. And this is consistent with what we mentioned earlier, right? When this condition is constantly false, it means no matter what value you give to A, you cannot make B active. Yeah, the condition you have to satisfy to make B active is constantly false. Has nothing to do with what value A has. Okay. Any questions? Let's do one more example. That's pretty mechanical, right? If you see what I'm doing here. So I'm going to do A. Why did you B? Which one you want to choose? A, okay, or anyone, okay. Let's do A first. Okay. So you're going to replace every occurrence of A with true to get B or C, right? Okay. And you can drop true from the conjunction to get B or C. A equals false, you're going to replace A with false. And you can get, basically you get false, right? And you make the condition you have to satisfy with the exclusive or of this two predicates. So you get B or C exclusive or F, right? What you get? You just drop F, right? Because if you want to make this is true, this true, B or C has to be true. And you can follow the process. I mentioned earlier, you get the same result. Well, let me just make sure you understand how to get rid of the exclusive or. We're going to do B or C and not F, right? That's one way to satisfy the exclusive or not B or C and F, right? That's how you get rid of exclusive or, right? And in this case, this is true, this can be dropped, B or C, and this is false, the whole thing can be dropped, right? So it's going to be false to get B or C. So it's going to be the same. Okay? Any questions on this? Do you want me to do another example like how to make B active, or you guys are okay? Okay, right? Okay. Yeah.
So what that result mean?
What does this mean?
Yeah.
It means if you want to make A active, B or C has to be true. This is the condition, right? The final condition. If you want to make A active, B or C has to be true. Okay. That means at least one of the two clauses B and C has to be true if you want to make A active. That is consistent with what you would get like utility. Are you guys okay? Let's move forward. Yeah. Which one? This one?
Yeah, previous one.
This one?
Yeah, this step.
This step?
Yeah, the next, yeah. So-
Okay. So which part you have a question?
Oh, this step is continuous? The last
Yeah,
one
yeah,
is-
that's one
Oh,
line.
that's one.
Yeah, yeah. This is how you get rid of the exclusive form, right? Yeah, because
It's like the two steps.
yeah, this is one step. Yeah. So exclusive or just remember this. X exclusive or is equivalent to X and not Y, or not X and Y. This is the basic formula we use to get rid of exclusive form. Yeah.
So do we do the same steps for B and C again, or do we stop at this A? Like finding out doing the P equals A equals true?
Well, if you are doing like active class coverage, remember, you have to try to test each class one at a time. So in practice, you have to test A, and test B, and test C. Okay. When you test A, you have to make A active. When you test B, you have to make B active. And if you are talking about the homework problems or exam problems, I'm going to tell you specifically which class you want to test. I may not ask you to test every class because that kind of repetitive. So probably I'm going to pick. In any case, I will let you know like which class you have to test. But in practice, you have to test every class. Yeah. Any other questions? All right. So now we know how to make the class active. That's the first requirement that you have to do when you do active class testing, right? Next, we're going to talk about how we're going to actually select the values, okay, to satisfy a given predicate testing coverage, not necessarily like active class coverage. We're going to talk about active class coverage later, but in general, if you want to have a predicate, how we're going to select values that satisfy coverage criteria that you have chosen to satisfy. So let's say we have a predicate. Okay. Again, a predicate is basically a branching condition, okay, in the source code. We kind of extract them off at this point. Later we talk about how we can actually test the program. So if we want to test this branching condition, okay, and predicate, I would say like a simple A represents like this relational expression. B, so A, B, C, they are classes. Remember, they cannot have any union operators, okay, but they could have relational operators. And these are like what A, B, C represents. Okay. So if you replace A, B, C with like what we have in the certain column, it looks more like a branching condition, right, in the source code. So how are we going to choose, let's say, values to satisfy predicate coverage? When I say predicate coverage, it means I just want to test the whole predicate true and false. Okay, that's what predicate coverage is defined. It's basically a branching coverage. So what we can do is that we can build the truth table for this predicate. So we have three classes, okay, and we have the 8 possible combinations. We evaluate the truth value of the predicate for each combination. And to satisfy predicate coverage is pretty simple. Right? You just divide all the test cases into 2 groups. In this case, test cases 1, 3, 5. If you look at 1, 3, 5, in these 3 test cases, the predicate, the entire predicate value is true. And all the other test cases, the entire predicate evaluates to false. So we divide all the possible test cases into 2 groups, okay? 1, 3, 5, and 2, 4, 6, 7, 8. And we pick one from the first group and the other from the second group. Then you're going to get 2 test cases that satisfy the predicate coverage. I hope that's pretty straightforward. But predicate coverage only requires the entire predicate to be true and false. Okay? So what this means is that you could have how many possible combinations you could have to satisfy predicate coverage for this predicate. You pick anyone from the first group and anyone from the second group. So you have 3 times 5, 15 possible combinations to satisfy predicate coverage. So again, the test set that satisfies the given coverage is not unique. Okay, you have many possible test cases that you can use to satisfy the given coverage. So this truth table is built in terms of the clauses A, B, C, right? So when you actually test the program, you have to give values to the variables, not only to the clauses, right? Like in this case, A represents, if you look at here, A represents, oops. A represents this relational expression. In this case, X and Y, they are the program variables you have. Okay, imagine how you write your program. Down would be a Boolean variable, a program variable you have, and this represents a function, a Boolean function. Okay, so when we actually test this predicate, you have to give values to those variables, those program variables, not only the clauses. Okay, so this is what we have here. Okay, if we want to, if we choose 1 and 2, okay, so 1 from the first group, 2 from the second group, that would satisfy the predicate coverage. So if we look at the first test case, all the clauses have to be true, right? So A, remember A represents X smaller than 1. So in this case, you could give any value to X and any value to Y, as long as X is smaller than 1. So in this case, the particular example, we give 3 to X and 5. And class B is a Boolean variable, and it has to be true, so we give true to this Boolean variable. And the class C is a function call, is a Boolean function call. Then you can create like a list and make sure the list contains the string that you want to check if it is in the list. Okay, so this value assignment would be what you're going to use to test the predicate when you actually deal with the program. We're going to talk more about how we're going to actually apply predicate testing to a program. Okay, if you look at the outline, that's what we're going to talk about next in more detail after we finish discussing how we can test individual predicates. Okay, then we're going to put it together. But in any case, okay, the point we're trying to make here is that when you test the predicate, in the end, you have to give values to the program variables, okay, not only the clauses. And for the second test case, okay, so it means A has to be true, B has to be true, and C has to be false. Okay. So this is what we have here. Okay. So X is smaller than Y, so A is true. The Boolean variable is still true, but if you look at the values for the Boolean function call, this Boolean function call will return false. Another point I want to make is that if you look at the two test cases, okay, even though A is true in both test cases, but you don't have to give the same values in the program languages. The point is that as long as you make the clause true, that is so you could give different values to X and Y, just to make X is smaller than 1, if you want to make this clause true. So this is how we find values to satisfy predicate coverage, right? So what about clause coverage? Right? So remember clause coverage, you have to test each clause true and false, right? So one way for you to do it is actually very simple, right? Like one way for you to do it. If you just want to choose, find two test cases, okay, to satisfy clause coverage, you just choose the first one and the last one. That would satisfy the clause coverage, right? But again, as I mentioned before, if you do predicate testing, minimum requirement, you have to test the entire predicate true and false. So clause coverage, if you just use clause coverage, you're not going to guarantee the entire predicate to be true and false. So because of that, in practice, people do not really just use clause coverage, okay? Because that is considered to be inadequate. Okay? So we're going to we're not going to get into much discussion for clause coverage. But if you really want to do clause coverage, you can always choose, okay, the first one. That would satisfy clause coverage. Of course, you could have other possible combinations, right? As long as you make sure each clause tested true and false. Okay. Let's say we have 5 more minutes, and let me see if we want to get started. Maybe I will stop. I don't want to rush because it's an important topic. And we're going to